Good morning, all. And the last lecture we discussed about the structure of B tree as well as B plus tree. Today we will be going to construct a B plus tree given a set of key values. As far as examination point of view, this is important. It has been asked in many question papers, but as far as syllabus, it is not mentioned explicitly as such. Okay. Insert the following key values: 5, 10, 25, 7, 22, 16, 33, 2, 12, 17, 21, 20. So our objective is to construct a B plus tree, not a B tree, with the following key values. And let the order of key tree is 4. That means in this tree you can have each root as well as intermediate node. You can have maximum of 4 tree pointers, a minimum of 2 also. And how many key values? If order is 4, means you can have maximum of 3 search key values. That is the structure of each of the root as well as intermediate node. In the case of leaf node, the structure is there is no, or the tree pointers are null, but every key value is associated with a data pointer that points to the block which contains this record. And what is the minimum number of data pointers in the minimum number of key values in each node, intermediate node as well as leaf node? The minimum is p by 2, the upper limit. P by 2 seal. In this case is p is 4, 4 by 2 is 2, upper 2 itself. For minimum it must have 2 key values, and maximum it can have 3 key values, a node structure. Let us start. And one more point, please understand that you are always going to insert the values in the leaf node. Therefore, what is the idea here is you search or look up to the search to the exact node, tree node, where the key value to be inserted. If there is space, you can insert. If there is no space, split that node into 2 and leaf node into 2 and move the middle value to the upper level. That is what is the idea. Always insert in the leaf node only, and whenever space you can insert. If there is no space, then middle value will be moved up. That is what the idea here. Now let us insert 5. Let us insert, we have a leaf node with a place for holding 3 values. You can insert 5, no problem. You can insert 10, there is space, no problem. 25, no problem. You can maximum of 3 key values you can insert. Whenever there is the after insertion of this will be looking like this. What is right, this yellow dot is indicating the data pointer 10, 25. Okay. Whenever you try to insert 7, what is the case? After insertion of 7, what will be the structure of the node? Because 7 you cannot insert in this node, it has to be split. Therefore, splitting means assume that the 7 is inserted, then how the ordering will be 5, 7, 10 and 25, and split in the middle. Split in the middle means here 4 elements, middle means 2 elements, 7 and 10. Which one will be select? You can select either 7 or 10. In our case, we will just take the 10, the right root node. Its structure is 4 tree pointers, and first pointer, the left of the key value, left tree pointer points to this node having 5 and 7. 7 is a newly inserted value, that is why it is shown in red. And on right side 10 and 25, you see here 10 is repeated here. But in the case of B tree, if it was B tree, then this repetition would not have been there, because 10 is again all the values should be present in the leaf node. That is why this 10 is repeated here. Because only here the data pointer is available. This 10 associated with this dot is showing data pointer. That is why every key value must be present in the leaf also. That is why it is 10 repeated here, and next is 25. Okay. And what is the next value to be inserted? Here structure is like this. Insert 22. When 22 be inserted, you have to search in the tree and find the appropriate place. Which is 22 is greater than 10. That is why we will be taking this path and will reach this node, this particular node. When this node is concerned, there is space for inserting 22, and new node structure will be 10, 22, 25, because always this values, key values, should be in increasing order. Now 10, 22 and 25 is the new inserted value. After inserting 22, 22 is inserted. Now this is a new structure, no change. What is the next value? 16 is to be inserted. Where to be insert? 16 is to be inserted. Again, it is greater than 10, that you will be taking this path, we will reach this node, and where 16, no space to insert 16. Again, it has to be split into 2. Therefore 10, 16, 22, 25 split into 2, 10 and 16, 22 and 25, and 22 has to move up, and there is space in the root to hold this 22. Now new structure will be 10, 22 and 10, 16, 22, 25. After inserting this, this is split into 2, 10 and 16, and other split is 22, 25. This is the value to be moved up, that is be placed here, and to the right of this 10 and 16, to the left, right of 10, 10 and 16, right of 22, the new value is 22, and again you see 22 is repeated in the leaf also. What is next? Now it is inserted 16. Now it's 33. Where 33 will come? It is greater than 22. That is why this is not. There is space. Therefore 22, 25 and 33. That will be the new structure after inserting. You can insert 33. Therefore here you can insert. Next value is 2. 2 also you can insert. 2 means it is less than 10, that is why we will move to this path. This path, there is space, therefore it will become 5, 7, 5, 7 become 2, 5, 7, that is why it is. Next value is 12, that also you can insert without much change, because there is space. They become 12 means 10, 12, 16. Therefore new structure after inserting 33 to 12 is like this, have no change. What is the value to be inserted next? It's a 17. Where to insert 17? 17 means we will take the path between 10 and 22. This is a tree where 17 to be inserted. 7 is the space, no space. Then it must be split into 2. How to split? 10, 12, 16, 17. The new node will be how many leaf node will be there after this insertion of 17? After the insertion of 17, there will be 4 leaf node. This is like 10, 12, 16, 17, and 16 will move up. And what will be the new? After inserting 17, the tree look like this. This structure of new tree structure after inserting 17. 17 comes to this 10, 12, 16 is split into 2. 10, 12 and 16, 17, and 16 is moved up. Now next we want to add 21. 21, as you know, 21 is greater than 16 and less than 22. Therefore this path we will take, and this is a node. Here there is space, therefore 21 will be added here. New structure will be 16, 17 and 21, no other difference. Therefore after inserting 21, the tree structure looks like this. Now the last node to be added is 20. Last data value to be added is 20. 20 is between 16 and 22. Therefore this is the leaf node where 20 is to be added. There is no space. It has to be split into 2. Therefore the split is 16, 17, 20, 21. These are the 2 newly added leaf nodes, and the 20 has to move up. When 20 is moved to the root node, the root become 10, 16, 20, 22. There is only space for 3 values. Now the newly added value 20, this root also needs to be split into 2. Now it is 10, 16 and 20, 22 are the new splits, and 20 moves up. Therefore, because of this addition of 20 here in the leaf node, here leaf node is split into 2, and now the root also split into 2, 10, 16, 20, 22, and 20 is the new leaf root node. And this is the structure after this. Here you can see 2 leaf nodes are created, 10, 16, 17 and 20, 20, 20, 21, and here you added 20, and because 21 and 20 is moved up, and when 20 is moved up, this root is split into 2, 10, 16, 20, 22, because 20 is avoided from this one, and because of that split, a new root, the new root is 20. Why this 20 is avoided from the intermediate level? Because in the case of B plus tree, every key value will be repeated, or will appear or should appear in the leaf, and there is no need to repeat a key value in the intermediate in several places too. That is why it is just avoided from this intermediate. Because of this split, our original algorithm says 10, 16, 20, 22, and 20 has to move up, and it's a repetition, and that is why the 20 is avoided from this intermediate level. It is actually present in the leaf node, and also here it is root is 20. To the left of 20, the left of 20 is 10, 16, and to the right of 20 is 22. Right of 20 is 22, starting with the node starting with 22, and actually this right of 22 is already 22 is starting node starting with 22, and this left 16, to the right of 16 16, and the left of 16 is 10, 12. That is why this is the new arrangement. And one more point I want to make it clear: in all the during the tree construction also, there is a link between root nodes. That is, there is a pointer from the every root node, every leaf node to other leaf nodes in the list. Now you see this is a pointer from leaf node 1 to leaf node 2 to leaf node 3, leaf node 4, leaf node. Here there is 5 leaf nodes. All the 5 leaf nodes are connected by pointers. The advantage of this connection is that you can perform a sequential search. Here you see the leaf node values are 2, 5, 7, 10, 12, 16, 17, 20, 21, 22, 25 and 33. The values 12 values arranged in sequential order. Therefore, you can perform a sequential search since the leaf level all the nodes are connected. Intermediate level there is no link between the nodes here, but in the leaf level there is a link between the nodes, so you can perform linear search if required also. Therefore, this is how a B tree is constructed. As an example, we construct a B plus tree, not B tree, B tree. This is B plus tree from the search key values 5, 10, 25, 7, 22, 16, 32. This many total values, and it is having 5 leaf nodes, 2 intermediate and a root node. Okay, thank you all.